Can you all see my screen?
Yep, we can.
Okay, one sec. I have to move some things around so I can actually navigate this. Okay, so I just put a couple links in the chat. One is to a GitHub repository that has a AWS link that you can run a Binder Hub version of this code. I'm really glad to be here. In 2018 at the Fall AGU in Washington, DC, I attended a Pangea workshop and I barely knew Python, so it was totally over my head, but I could hit Shift Enter in the tutorial cells that they were running and nod along and blend in. But the vision that they presented, it was just so compelling that I've been haunting them ever since. And we started talking a lot about science and cloud computing, and these are conversations with like Ryan and Jim and Chris and Yuvi. And so I dropped a link to a paper that we just published called Science Storms the Cloud that sort of talks about this vision. And Ryan's posted a couple of things. There's been about 3 papers out recently. And today I'm going to talk about sea surface temperature data sets, which are sort of my interest and research focus. I'd also like to welcome, we have SciParks going on that just kicked off this week. A lot of people from Pangea are involved in mentoring students this year. And several of us, Kevin Paul, Julia Kent, and myself are working with Lucas Stergenser and cloud optimized satellite data sets. And I'm going to be talking to you about SST. So sea surface temperatures, the GRIST project started about 24 years ago now. This is just a picture of the website. And at that time, all of the different data sets were really scattered. They weren't in, one would be in HDF and one was in flat binary. And they were just sort of a mess. And you had to go to all these different FTP sites to get access to them. And it was really hard to read.
Okay, luckily I have 2 computers set up next to each other, so I just switched over. So I put a link in the chat to a repository, and that OSM repository looks like this. And if you go down, you can click on US West 2, and you can actually run all of this code yourself. I'm just going to show you one. I have also saved the results, so where it's run in that. And what that looks like is, this is a tutorial about accessing different cloud data sets. And one of the things that I really struggled with when I started moving to the cloud was just getting data. There's so many different ways to read data, and there's so many different ways to access data, whether it's on an S3 bucket or in a Google bucket. Are you using Bodo or using FSPec? So I've written a couple things showing accessing different types of data sets. And satellite data comes in 4 different levels: level 1, 2, 3, and 4. Most of you probably won't ever deal with level 1 data. It's just the raw observations. You may deal with level 2, especially if you're interested in gradients. It's derived geophysical variables where the satellite observations has been gone, they've been run through an algorithm, and now you've created a retrieval, but they're not remapped. So they still, each observation has a lat along and a timestamp. Level 3 is where you start to remap them. And then level 4 is where you're doing some sort of analysis on them to maybe fill in gap or bring together multiple sensors. And so this notebook, I won't have a lot of time to run through all of it, but what it does is you can run through it on that Binder Hub link. And it talks about how to find data sets and to show you how to explore them using HTTPS on S3 buckets. And the first one is a data set called MER. And this is a czar version of the data set. So you can go to the PODAC, which is NASA's data archive, and you can download individual daily NetCDF files, and it'll take you a week or longer depending on your internet connection. But working with Amy Barshoskas from DevSeed and Zach Flamig from AWS, we've put a czar version of that onto AWS that you can access really easily and quickly. And to just show you how this works, I'm going to import some libraries, and then this is showing you what the data looks like. So all I have to do is give it the file location. I use FSspec to get a mapper, and then I open the czar. And I sort of have instantaneous access. It took 3 seconds to run this. And one of the powerful things about Xarray is you get this instantaneous access to data sets, but you can also explore them really easily. And so here you can see the SST, the error, a mask, and a sea ice fraction. And you can look at these data sets and you can see how they're chunked. You can look at the metadata. You can visualize them. And I find this really helpful. You can read 10 years of data set, and in about 3 seconds, I can plot a time series going from 2010 all the way to 2020. And this is just really transformative, because before, with daily NetCDF files, this would take a really long time just to create this figure. And when you're doing science and when you're exploring a data set and trying to explore what you're thinking about and how you're thinking about things and what you're looking for, being able to have fast access to data sets like this and to be able to select time slices and latitude and longitude in ways that are really intuitive to a scientist. You don't have to translate it into an I and a J coordinate system. You can keep it in your mind and you can ask for it how you think about it, which is latitude, longitude, and time. And I think that that really changes how scientists interact with data, because it hides a lot of the formatting and the structure behind it. So this notebook runs through using MER. It shows you some of the details and why you need to be careful when you're using satellite data, well, any data set. It's useful to plot it and to look at it. And for example, if you don't apply the sea ice mask, and you just looked at a time series at a high latitude, it's just set to minus 1.8 when ice is present. And so if you were calculating a mean or doing a climatology, you'd want to understand when to mask that data. Also, that when you're given data, it's important to understand it, and that this is just 2 images of the San Francisco Bay Area from 2 different times. And in this area, this is a ocean temperature product that blends together low and high resolution data. And on this day, the high resolution data was obscured by clouds, so it wasn't available. And so the temperatures look sort of blurry because it's lower resolution data. That same data set on a different day, you start to see a lot more fine scale, mesoscale structure. And it's really important when you start to use these data sets to spend a little bit of time exploring them, because you're more likely to get accurate science results if you understand the data better. And one of the powers of doing this sort of scalable analysis on the cloud and accessing these czar data sets is that you can do that exploration and really start to understand your data set so that you ensure that any results you get are meaningful. The notebook then walks through doing the same thing with GOES, and it makes some images of looking at the GOES data sets that are on AWS. And those are really neat, very powerful, high resolution sea surface temperature data sets. And they're just beautifully high resolution. Next, I go through Himawari, which is a Japanese satellite. And I'm going to switch over here to one that's already run so we can see some of the images. Sorry, I'm scrolling fast. Please don't get motion sickness. And then I'm going to go, then it goes through ERA5. So ERA5 is a really big data set. Pangeo has a ERA5 czar that's really easy to use, but it doesn't go, it doesn't include the most recent data. You can also get ERA5 on AWS. It's a little bit of a pain to read. It's not, but there's some routines that make it fairly easy to read. It's not as nice as the Pangeo store, but you can read it, and it has a lot of the number, it has a number of the variables, but not all of them. And you can make images and time series. And the Pangeo czar store for ERA5 is definitely easier to work with, but if you need more recent data, then you need to go to AWS. And that's it, because I don't want to make sure we have enough time to have our community meeting. So if you have questions about this, feel free to ask me. Either drop me a line or we can talk later. We can talk now too. But I mean, that's one of the powers of Pangeo, right? Is we all get to ask questions. Ryan knows that I always